unbelievable new worlds. Planets made of diamond, planets of raining glass, worlds in collision, some plunging into stars, and others that just might harbor life. But had ancient astronomers as far back as the days of Greece and Rome already guessed what modern science is about to learn?
We are the generation of human beings that are going to know whether or not we're alone in the universe.
Ancient mysteries shrouded in the shadows of time. Now, can they finally be solved by looking to the heavens? The truth is up there, hidden among the stars, in a place we call the universe. Ancient Greece. The greatest minds look up in wonder at the strangest objects in the night sky. 5 brilliant points of light that look like stars, but move in mysterious ways.
They noticed that some objects didn't behave like the stars, and that they called them the wanderers. And they mapped them out in incredible detail.
The ancient Greek word for wanderers is planets. 2,000 years later, the invention of the telescope added 3 more planets, bringing the accepted total to 8. But if anyone thought that these were the only planets in the universe, they were dead wrong. The problem was, for years, there was simply no way to find any additional planets that theoretically might exist around alien stars.
They didn't know how to find them because looking at them with a telescope, they're just invisible to us. They're too small.
Scientists compared the challenge of finding such planets to placing a firefly next to a Hollywood spotlight.
Now, imagine flying to New York City and taking your best camera, attaching it to your best telescope, and trying to take an image of that spotlight and that firefly all the way out here in Los Angeles, where you can see the firefly separate from the spotlight. And that's about the scale of how difficult it is to actually take a picture where you can see the planet next to the star.
Yet in just the past few years, we've discovered hundreds of new planets whirling around alien suns. It's a collection of worlds that range from the bizarre to the eerily familiar. A planet about to be swallowed by a dying star. Giant water worlds awash in global oceans. A planet in a death plunge into its star. 2 planets in the fiery aftermath of a gigantic collision. And the Holy Grail, Earth-like planets that just might harbor life. Could this be one of the first places in the universe we find alien life? A newly discovered planet called Gliese 667 cc. It orbits what's known as an M dwarf, a star that's a third less massive than our sun, and gives off a tiny fraction of the visible light. But for astronomers seeking both new worlds and life in the universe, it looms large. Because planet Gliese 667 cc might actually be inhabited, even though it's 8 times closer to its dim star than Earth is to the sun.
If we on Earth were orbiting the sun at that distance, we would get fried. But because Gliese 667 is a low luminosity M dwarf, a dim star, the planet 667 cc that orbits it actually gets an amount of starlight that should make its temperatures somewhat comparable to those that we have on Earth.
So what would it be like to stand on the surface of this world and look up into the sky? Here we are on Earth. That's our sun up there. It's so small, I can take my little finger and block it out. But on Gliese 667c, come on, the sun is 10 times larger.
The energy pouring onto the planet is not visible light, like on Earth, but infrared light, otherwise known as heat. Because the planet orbits so closely, it's locked in the tidal grasp of its star.
It's the same side always that faces the star. It's like the moon. The same side of the moon continually faces the Earth. Well, so too, the same side of this planet continually faces Gliese 667c.
Scientists once thought that such planets would be too hot for life on one side and too cold on the other. But simulations now suggest that heat from the hot side would flow to the dark side and vice versa, evening out the temperature. If life exists in this bath of infrared light, it must have evolved far differently from life on Earth. With eyes adapted to the infrared spectrum,
If you imagine taking night vision goggles or something which lets you see infrared light, you would see that, in fact, everything around you was glowing, and that the amount which it glowed varied depending on the temperature. Things which are hot will be brighter, things which are cold will be fainter.
plants too would have evolved in ways hard to imagine.
On Earth, everything is green because that's the wavelength of light plants don't like. They take in the red, they take in the blue for energy, and they reject the green. So we live in a green world. But on one of these worlds, as the infrared wavelengths are brought into the plants, everything to us would look black. Could you imagine rolling fields of black grass?
If life can survive the turbulence of an M-dwarf star like Gliese 667c, that would have profound implications for one of humanity's greatest questions. How common is life in the universe?
The reason for that is that M-dwarfs are the most common kinds of star. It might surprise you to learn that when you look up at the night sky, even if you're in a very dark place and you can see lots of stars, you can't see any of the stars that are the most common kinds of stars in the entire universe. 70% of the stars in our galaxy are what we call M-dwarfs, very cool, small red stars that are half the size of the sun or even smaller than that.
Yet these dim suns, invisible to the naked eye, may be humming with life.
We've learned that these are the most likely stars to host planets that are roughly the size of Earth, at roughly the right distance away from their star that they receive similar amounts of light from their star that we receive here on Earth.
One thing seems sure. If life exists on Gliese 667cc, it would have far more time to evolve than life does on Earth. Our sun will only last a few billion more years before swelling into a red giant and sterilizing the planet. But M-dwarfs are practically immortal.
We think that there are some of these stars which live basically the age of the universe. So that's an advantage because we know that our sun isn't going to live forever.
Gliese 667cc is just one of dozens of Earth-like planets that researchers have recently discovered. Planets that finally confirm the beliefs of ancient philosophers who taught that there were countless alien worlds. But as we look at these new alien planets, an even bigger question emerges. Is anyone looking back at us? We finally have the technology to find out. As we search deep space for alien worlds, the ancient understanding of what it takes for a planet to support life is encoded much closer to home. When the Apollo mission landed on the moon's Sea of Tranquility in 1969, many people wondered about the name.
Tranquility Base here. The Eagle has landed.
Why Sea of Tranquility? The answer goes back to an ancient belief about life on other worlds. In the 1st century AD, the Greek philosopher Plutarch wrote that the moon was a planet like Earth, and that it might even be inhabited. If so, he argued it would need oceans of water.
Even back to the days of Plutarch, we realized that water was necessary for life. Some people think wine is the elixir of life, but in the scientific world, we realize it's water.
Ancients like Plutarch looked for lunar oceans and thought they saw them in the dark splotches scattered across the moon. So they named them mares, the Latin word for seas.
So we have the Sea of Storms, the Sea of Tranquility, all these different seas. The idea that water was very critical to life goes way back in our historical records.
Today, we know that the moon's seas are simply large basins of dark volcanic rock. But Plutarch's original idea that to find life on other planets, look for liquid water, has survived the test of time.
All known life on Earth appears to require the presence of liquid water. Molecules can get bigger and can form complex structures. If life elsewhere is like life on Earth, then the mantra should be follow the water.
Water is common in the universe, but liquid water is rare. On the surface of planets, it only exists in the so-called Goldilocks, or habitable zone near a star, where things are not too hot and not too cold. The size of this habitable zone depends on the size and temperature of the star that the planets are circling.
Our sun is a fairly ordinary mid-sized star, so our habitable zone where Earth resides is 1 astronomical unit away, way out here, millions of miles. Now, in the case of low-mass stars, they're much smaller, and they have much less luminosity or light output. So that means that the habitable zone goes from being way out here to being much closer in to the central star.
So life could exist on planets much closer to dim stars. And as we've seen, the universe is teeming with planets like that. Another key thing that affects the possibility of liquid water and life is the planet's size.
If a planet is too small, we think it will lose its atmosphere because it does not have enough gravity to hold on to its atmosphere. That's what happened to Mercury and, to some extent, Mars. If the planet's too big, it becomes a gas giant, which actually are very hot planets as one would travel down into the atmosphere. So the planet has to be just the right size.
So the habitable zone is actually the sum of 2 parts. One is being the right distance from the star, and the other is having the right kind of planet.
These, then, are the 2 requirements for life. But how often do they exist? It turns out they're everywhere, including here, on this incredible newly discovered planet called Kepler 22b.
Kepler 22b is what we call a super-Earth. These are planets that are larger than Earth, but smaller than the planet Neptune.
We don't have anything like that in our own solar system, yet these planets appear everywhere when we look at other stars.
As the list of planets that fit these precise requirements grows, the surprises keep coming. Consider an alien star only slightly smaller than our sun that has not 1, but 2 planets that might be in the right spot and be the right size to harbor life.
Kepler 62e and F are both super-Earths. They've got about 1.5 times the diameter of the Earth. And both of them are in, broadly speaking, the habitable zone.
They're so close to each other that if technological beings evolved on one, they could easily visit the other.
If you could travel in a rocket ship, it would take about 12 days to go between these two worlds.
That could only happen if these planets have dry continents. But some suspect that they're water worlds covered in a deep global ocean.
These would be planets with a small rocky core and then a very massive water envelope surrounding that. So that would certainly be an example of a kind of planet which is fundamentally different than anything we see in our own solar system.
A water world might be great for life, even intelligent life, but technological civilization is probably impossible for a simple reason.
You can't light a match underwater. You can't have electricity. Probably intelligent life that is capable of making and building things wouldn't exist there because they can't use fire.
Still, this does not rule out life in the atmosphere. After all, some fish on Earth have evolved flight to escape predators. So scientists speculate that the skies of Kepler 62e could swarm with alien birds. Planets like Kepler 22b and surprising twins like Kepler 62e and f are revolutionizing our understanding of what kinds of worlds might harbor life. But how does this strange class of planet make our solar system look like the freak of the universe? As we searched the heavens for new worlds, we expected to find solar systems that look like our own. But instead, we're discovering that our solar system might be a freak of nature, challenging a view of the cosmos that developed over thousands of years. Some astronomers in the ancient world correctly guessed that Earth was a globe that revolved around the sun. But the most famous of all ancient philosophers strongly disagreed. In the 300s BC, Aristotle argued that the Earth was at the center of the universe, and his ideas were accepted for centuries.
The Catholic Church adopted this because it worked so well in their theology of how the universe worked. God had created man, man was special, the earth was special. And because of this, this is what everybody believed.
It wasn't until the 1600s that Copernicus proposed that we inhabit a solar system with the sun at the center and all the planets revolving around it, including Earth. By the late 20th century, scientists believed that they fully understood the mechanics of how solar systems evolve.
For many years, the only example of a solar system that we had was our solar system and the 8 planets that orbit here around our sun.
We based our entire view of how solar systems are born on our own solar system. But the sudden discovery of thousands of exoplanets has shown that apparently we were wrong.
Now we have a plethora of different systems, all of which are totally different, and some very similar to ours, and then some very alien.
The way our solar system formed produced essentially 2 kinds of planets.
One type is the rocky planets. We call them terrestrial planets. The other would be giant planets like Jupiter and Saturn.
This made sense because of how we thought solar systems evolve.
When solar systems form, they collapse from a large cloud of gas, and the central mass of them becomes the star, whereas the disk of material that's left over around that central star becomes the planets.
Close to the star's warmth, the most common elements, hydrogen and helium, are heated into gases and blown away by solar winds. So near the star, the only materials left for making planets are heavier rocky elements.
This is where it's warm enough that you can really only condense out rock and metal to form these little planets. However, further out in the solar system, beyond what we call the snow line, temperatures are cool enough where you can condense gases and form these very large envelopes that eventually become planets like Jupiter and Saturn.
We thought this is the plan for all solar systems. Boy, were we wrong.
The tip-off for how wrong we were was the discovery of a class of exoplanets that theoretically can't exist, except they do. The so-called hot Jupiters.
A lot of the first exoplanets found are what are called hot Jupiters, big, massive planets that actually orbit very close to a star, having an orbital period of a day or only a few days or 10 days.
HD 209458b zips around its sun-like star in 3.5 days. While our sun's closest planet, Mercury, takes 88 days.
HD 209458b is an iconic planet. We also think that the atmosphere is being blown off by interacting with the star and heating up, and by wind from the star hitting the planet, and its atmosphere will be slowly whittled away.
Losing about 10,000 tons of gas every second, this planet is, in effect, evaporating.
It looks like a comet with a huge tail stretched out behind it. Eventually, that atmosphere is going to be gone, and all that's going to be left is a little molten core of what this planet used to be, orbiting nearby this bright star.
But these hot Jupiters are far too close to their stars to have formed there originally. So what happened? Scientists now believe these hot Jupiter solar systems began like ours, with the gas giants forming out past the snow line. But then the gravitational pull of the disk, or of various planets, or even passing stars, caused the orbits of the gas giants to go haywire. They migrated inwards, spiraling toward their suns, and that process spelled doom for the smaller Earth-like planets closer to the star.
Well, you'd have the star over here, you'd have a Jupiter-sized planet here, and as it moved in, the little rocky planets would either be thrown into the star or thrown out of the solar system, or they could be captured by that big Jupiter and orbit around it like a moon.
The planets tossed out of the solar system are doomed to wander forever in deep space. Some researchers now believe that the galaxy holds billions of these dark, lost worlds. So it turns out that our orderly solar system, with the rocky planets close to the sun and the gas giants further out, may be a lucky exception.
Earth has achieved a stability that allowed life to develop and evolve in a relatively unhassled way for billions of years. And in many other planetary systems, that may not be the case.
But while the discovery of new planets has challenged some ideas of how solar systems evolved, it's confirming others, including the catastrophic idea of colliding worlds, and even how the Earth will one day die. Many ancient ideas about planets seem simplistic. But around 400 BC, the Greek philosopher Democritus proposed ideas that seem straight out of a modern science textbook, including ideas about fiery cataclysms in the Earth's past, and a terrifying idea about how the Earth will one day die.
He was the first to come up with the idea that things were made of smaller things. He called them atoms. And they came together and grew into stars, into planets, and into everything that is around us.
When it comes to planets, Democritus wrote that, quote, there are innumerable worlds of different sizes. In some, he wrote, there is neither sun nor moon. In others, their sun is larger than ours, and others have more than one sun. All of which, amazingly, is true.
The interesting philosophical question is, how did he come up with this idea? It shows the uniqueness of the human mind to be able to project and ask what if, and then, using logic, put together a philosophy of how everything works.
Today, as we discover planets around alien suns, many of Democritus's ancient ideas have been confirmed by modern science. For example, he wrote that some planets are destroyed by collision. And now, we're actually watching that happen. This is the hot Jupiter called WASP 18b, a planet caught in the act of plunging into its star.
It's been orbiting for possibly 2 billion years, but within the next million years, it's going into its star. And the whole shape of this round world would be stretched like an egg.
While WASP 18b confirms Democritus's idea of how planets can die, another new discovery confirms his ancient prediction that planets can crash head-on. The planet HD 172-555 is a world in the aftermath of a collision.
What we think we're seeing is two large rocky planets which have just crashed into each other, thrown up a bunch of dust, melted rock, kind of accreted together.
Scientists have long speculated that a collision like this happened to the early Earth, tossing up debris that created our moon. For decades, that was just a theory. Now, they can actually watch it happen.
Gases were given off. Glass was created, and now they're fusing back into this remain of this world that will be cooling down. But right before our very eyes, there's a space wreck right in front of us.
Democritus's ancient theories about the death of planets are bolstered by another major discovery, a dying planet called Kepler 91b. Scientists have long believed that in the distant future, the sun will swell up, engulfing the dying Earth in an inferno.
And this isn't just a theory now, because we think we see this with Kepler 91b.
Kepler 91b's star, about the same mass as the sun, is already swollen into a red giant. It's now about 6 times our sun's radius, and growing rapidly. If there were oceans here, they're already evaporated. If there is life, it's in trouble.
On this world, if you wanted to see life, you'd be there at night. Everything would come out when it's cooler. And then in the day, it would disappear once again. And the most precious commodity on this world would be water. Everybody, everything would be looking for water. And yet, this is our future. We're seeing it now.
Like Earth, Kepler 91b is doomed to be swallowed by its sun. Unlike Earth, its time is almost up. But could a planet survive that fate? Apparently, we've found one that did.
V391 Pegasi is an example of an exoplanet that has physically survived the red giant stage of the star that it orbits.
Its sun turned into a red giant and grew larger and larger and larger until it actually consumed this world. And then as its sun has shrunken back down, the world remains.
Since V391 Pegasi is still there, it's the first known planet to survive a close encounter with the kind of red giant that will one day threaten to destroy Earth. If you can call that survival.
That world now is one burnt, rocky planet. Anything that was living is gone. It's disappeared.
Newly discovered planets like these give us a glimpse into Earth's future. But there are other planets out there so strange, they seem ripped from an alternate universe. What is mankind's secret weapon for unmasking these mysterious worlds? Less than 20 years ago, scientists were still struggling to discover a single planet outside our solar system. Today, we've discovered thousands. How did we do all this, and do it so quickly? The revolution begins in the 1990s. Scientists knew that planets cause their host stars to wobble, and finally developed a way to detect this.
We now had instruments with microelectronics, a spectrograph, that could act like a policeman's radar gun. We could take a look at a star and we could see if it was moving towards us or away from us.
Using that technique, scientists discovered something that had eluded not only the ancients, but even modern astronomers. The very first planets outside our solar system. But were there even better ways to search?
Once we knew there were planets around other stars, people suggested that there might be another way in which you could find planets.
That way was to look for little eclipses caused when the planets passed between their host stars and our vantage point on Earth. These tiny eclipses are called transits, like the transit of Venus we saw from Earth in 2012.
This creates a tiny dip in the brightness of the star, which we can measure as it happens again and again as the exoplanet goes around in its orbit.
But from Earth's surface, the transit technique had serious limitations.
You really need to monitor the star all the time without interruption in order to have a good chance of not missing any transits.
That's where NASA's Kepler Space Telescope comes in. Launched high above Earth's distorting atmosphere, it pointed at just one spot in the sky, a field of 150,000 stars, taking continuous pictures of that region over and over again for 4 years with space-age precision. Would it find a sky brimming with planets or a dark and empty void?
Lo and behold, planets started moving across their stars, and we started seeing their orbits, and we waited and waited another year, another crossing, another year, another crossing.
But scientists quickly turned to a larger question. Could any of these planets be similar to Earth?
The majority of the stars in the Kepler field seem to have planets. And Kepler was actually sensitive enough to detect a planet the same size or even smaller than the size of the Earth. And it found enough of those that we now know that small planets are much more common than large ones.
That, in fact, was Kepler's revolutionary purpose: to find Earth-like planets that could harbor life.
In this mission, we found them, but we found a lot of other surprises too.
But as scientists struggled to discover the total number of planets that exist in the galaxy, they ran up against Kepler's major limitation. It can only spot planets that transit their star as seen from Earth, and most planets do not.
If we have a transiting planet system, then we need the alignment to be perfect for that planet to go around its star and to block just a little bit of that light from getting to us from our point of view. However, if we took this system and we tilted it up such that the alignment no longer happened, then the planet would still be going around its star, but it would never block any of the star's light from getting to us, and we wouldn't see a transit at all.
Scientists realized that the chances that an Earth-like planet will transit are 1 in 210. Using that ratio gives us a staggering estimate of how many planets actually exist.
What this tells us is that in our Milky Way galaxy, which has between 200 and 400 billion stars, there may be almost 230 million other planet Earths out there.
Once Kepler detects a possible planet, scientists across the globe race into action.
Another group of astronomers takes over with telescopes here on the Earth with huge spectrographs, and they take a look at this world and look for the star to wobble. We need both these processes now to determine what the planet is and how far away it is and what it looks like, and even what it's made out of.
Kepler roared into space in March 2009 on a Delta II rocket. In the first 6 weeks, it discovered 5 previously unknown worlds. Today, it has discovered thousands.
It's nearly impossible to describe how revolutionary Kepler was for exoplanets. Kepler made so many discoveries we never even expected.
So far, some of the newly discovered planets have challenged, and others have confirmed, ancient theories of how worlds are born and die. But even the ancients never dreamed of the kinds of wondrous worlds we're discovering today. How does the universe make a planet of solid diamond? Ancient philosophers like Democritus believed in a universe aglow with amazing planets. But today's planet hunters have discovered worlds far stranger than the ancients ever suspected. You are orbiting 55 Cancri E. It's mostly made of carbon, and due to extreme pressure and a surface temperature of 4,892 degrees Fahrenheit, it just might be a jeweler's dream.
Now think about this. What happens if you take a piece of carbon and you have the strength of Superman and you crush it like this? What do you get? A diamond.
If a diamond planet isn't strange enough, let's descend to another new discovery, HD 189773b. Its blue color makes it look surprisingly like Earth. But in this case, looks can be deceiving.
This is a glass planet. It has mostly silicon, and the silicon with the sunlight passing through it appears to be blue, and it's very hot.
In fact, the temperatures near the surface are such that the silicate can condense into fine little particles of glass, so it might actually rain glass on this exoplanet. But that rain would move largely sideways because there are huge winds in the atmosphere, up to 4,000 miles an hour.
And the ancients never predicted a planet covered with a seeming impossibility: burning ice. Yet that's what we find on Gliese 436b.
If you touched it, you would be burned. This is a world made of hot ice. Something we never imagined on Earth.
Diamond planets. Planets of raining glass. Worlds of burning hot ice. Thanks to projects like Kepler, the universe is proving far stranger than either the ancients or modern astronomers ever imagined. But more is soon to come. Scientists are bracing for the discoveries of TESS, the Transiting Exoplanet Survey Satellite, due to launch in 2017. Unlike Kepler, which looks at one patch of sky, TESS will scan only the stars that are so close we might actually visit them someday.
We're mapping the nearby stars for planets that we hope eventually in the future our descendants will actually be able to travel to. So we have a huge interest in trying to find planets orbiting stars that are very close to Earth.
Other new projects have actually begun searching not just for life, but for intelligence and technology. One surprising key is to look for stars that twinkle and pulse in bizarre ways that could only be caused by advanced alien civilizations.
I used large databases of observations of stars to try and understand whether any of those stars could be varying in a way that was caused by something artificial.
But can we ever visit the planets we are now discovering in such abundance?
I'm hopeful that at one point we'll eventually be able to send robotic probes to some of these nearby solar systems.
Not everyone believes that it'll happen, but we're born explorers. We'll want to go. We have to have hope that in the future, if there's a will, there's a way.
Whether such a thing will happen is anyone's guess. But one thing is certain. Thanks to today's planet hunters, our views of the universe and of our place in it are undergoing one of the greatest revolutions in scientific history.